Here we have a relatively complicated circuit, so a number of capacitors, 5 capacitors. We're told that we have a 6-volt battery. We're given the capacitance values, just farads, a 1, 2, 3, another 3, and a 3/2 farad capacitor. So we're given those values, and we're asked to find all of these things: the equivalent capacitance, the equivalent charge, the charge on the Q2, the C2 capacitor, and the voltage at points A, B, C, so the green, and then I guess that's it. The black is the 0 volts. So the first thing that I would like you to do, and do with me here, is just in the original circuit. Don't worry about anything else, but just color code or shade, whatever you have to do to get all of your same color, same voltages in. So we know the red is 6 volts. We know the black is 0 volts. So we have 0 volts, 0 volts, same color, same voltage. And that's all we know, right? So we don't know the pink, we don't know the green. Now what we're going to do, as it says here, I indicated before in the notes, but it is very helpful to work to at least start by looking at the furthest point and working your way backwards. I hope you can see that we have 4 and 5 in series. The same flow of charge will go through 4 that then goes through 5. So I have C45. And I'm redrawing the circuit here, making it as hopefully as clear as I can to you. So once 4 and 5 are together as one capacitor in that branch of the circuit, hopefully you can see that 3 and 4 and 5 are in parallel. So they get put together as one. C2 then is in series with 3, 4, 5. So I get 2, 3, 4, 5. C1 is in parallel with 2, 3, 4, 5, and we get our final equivalent circuit, 1, 2, 3, 4, 5, the equivalent capacitance with our battery voltage. So let me zoom back out here. Please pause the video and make sure that you completely understand the work done up to this point before going on to any of the calculations. So pause the video, get all this down, ask questions if you have to before going on to the calculations. Okay, hopefully the diagrams are understood by you, and let's see how the calculations work out. Well, here we are taking the equivalent capacitance. So you always want to find the equivalent capacitance first. So we are taking 4, 5. So 4 and 5 are in series. They add reciprocally, and then we invert, but the reciprocal of 1 is 1. So we get C45 is 1. We have 4, 5, and 3 in parallel. So they just add 3, 4, 5. 3 plus 1 is 4. We then have C2 and 3, 4, 5 in series, so they add reciprocally, and then we invert to get the equivalent capacitance, 3, 4. And then our last step is to take the parallel combination of 1 and 2, 3, 4, 5 together to get our equivalent capacitance. So that is the first thing you always want to do, regardless of what else is asked within the question. You have to get the equivalent capacitance correct. And then from the equivalent capacitance, you are definitely going to take the battery voltage. Take the battery voltage, the 6 volts, and your 0 volts, and use that 6-volt voltage drop to calculate the charge on the equivalent capacitance. So we know everything about this final part of the circuit. That is what you always need to do first. You then want to work your way up. So when we go up, what do we know? Well, we know same color, same voltage. So we know we have 6 volts across the first capacitor, so we know everything about capacitance 1, and we know we have 6 volts across 2, 3, 4, 5. In this case, we're interested in the 2, 3, 4, 5 based on what we were asked to solve, so that is what I look at next. So in going from this 2, 3, 4, 5 back up, we had 2 in series with 3, 4, 5. So what I did was looked at the charge on 2, 3, 4, 5. So I know I have 6 volts across 2, 3, 4, 5. And I know the capacitance is 4/3, so I know the capacitance, I know the voltage, I know the charge on 2, 3, 4, 5. Well, if I know the charge on 2, 3, 4, 5, then I also know the charge on capacitor 2 and the charge on capacitor 3, 4, 5, because capacitors in series have the same charge, and they have the same as the equivalent capacitance. Now, once I know the 8 coulombs is on capacitor 2, I can take that 8 coulombs on capacitor 2. I was given the capacitance to 2 farads, so I know I have a 2-volt voltage drop when I go across, or I'm sorry, a 4-volt voltage drop when I go across capacitor 2. So if I started with 6 volts over here, I have my 4-volt voltage drop, which means I have 2 volts. Oops. 2 volts is my pink voltage. So my pink voltage, the voltage at B has a voltage value of 2 volts. So that B is 2 volts. Now we're also asked to calculate the voltage of the green. So to get the voltage of the green, we are going to go over here and see that the charge on 4, 5. So where's 4, 5, Q4, 5? The charge on 4, 5, right? We know the pink is 2, right? The blue is 0 volts. So I know the voltage drop across 4, 5, that's 2. I know the capacitance of 4, 5 is 1. So I know the charge on 4, 5 is 2. Once I know the charge on 4, 5 is 2, that's the same as the charge on 4, which is the same as the charge on 5. So it gets a little bit complicated. So the same as the charge on 4 and 5, same as the charge on 4, so we get the 2. We know the capacitance of capacitor 4 is 3, so I know the voltage drop across capacitor 4 is 2/3. So we go from 2 volts is my pink. I have a 2/3 voltage drop. So my green voltage is actually 4/3 of a volt, and that's what I have down here, my 4/3 of a volt. So it definitely gets a little tricky in doing the calculations, so please go back and look at whatever you need to look at to follow through the explanation, and of course we can talk about this in class.